To understand average rate of change of a function, we first need to recall the slope of a linear function, which is the average rate of change over the whole function. The slope is constant for a linear function. So for a linear function, it doesn't matter what part of the line you're looking at. It is simply a characteristic of the whole line. It's a characteristic of the whole line which can be determined from any 2 points on the line. When we generalize that to average rate of change, it's the same formula. But for average rate of change, we do need to specify the points x1 and x2. And we can't talk about it as a characteristic of the whole function. We talk about it as a characteristic of that part of the function. For example, what is the average rate of change from x1 to x2? And because we tend only to talk about average rate of change in the context of functions, the formula is written using function language. So this f of x2 minus f of x1 is the same thing as y2 minus y1. It's the same thing as the difference between the y values, but generally we're finding those y values by evaluating a function. So we're going to go ahead and apply this formula to a graph and to a function that is defined symbolically and see how it is that we adapt our thinking to those two situations. First, we will look at a graph. We are asked to find the average rate of change of the function defined by this graph from 0 to 2. This wording sometimes just gives the x values without labels. It might say from x1 equals 0 to x2 equals 2. Or it might just say from x equals 0 to x equals 2. All of these are saying the same thing. We are specifying x, but we're using the function to find y. So here's x equals 0 happens to be also at the origin where that graph is. Here's x equals 2. I'm going to trace to the function and find a point on this graph that has x coordinate 2 to get the other endpoint. So even though I had a formula for average rate of change, I'm going to use the fact that it's the same as slope, which is easier to work with here. If I just draw in a line segment connecting these 2 points, now answering this question is the same as finding the slope of the line segment connecting those 2 points. So I can see, first of all, this is a positive slope. So I'm going to call it m. M is equal to a positive number because as I read from left to right, it is increasing. It has a run of 2 and a rise of 3, so it's positive 3 over 2, and therefore my average rate of change of the function over those 2 points, or between those 2 points, is equal to 3 over 2. Now I will continue with this idea to answer the other questions. You might pause the video right now and try this yourself and then just check your answers. Looking at from x equals 1 to x equals 4, I now find x equals 1 and mark the point on the graph. X equals 4 happens to be, the graph happens to be right here at the x-axis. So I will now draw the line that connects these 2 points, and that slope is m equals, I can see that this one is a negative slope because as I read from left to right, it is decreasing. It has a rise of 2 and a run of 3. So this slope is negative 2/3. Lastly, I will go from 5 to 7. Here's x equals 5. Here's x equals 7. Tracing to the graph for both of these points, I get these 2 points which are connected by a horizontal line segment. Because the slope of any horizontal line is 0, the average rate of change of this function from x equals 5 to x equals 7 is going to be simply 0. So if we have a graph, we should not try to use the formula for average rate of change. We should instead try to draw a picture of that line segment and figure out what its slope is by analyzing it. What's the rise? What's the run? Is it a positive slope or a negative slope? And then everything's very simple. When we're working with a function that's defined symbolically, it's usually best to use the formula to answer questions about average rate of change. This could have been phrased from x1 equals 7 to x2 equals 23. It could have been simply phrased as from x equals 7 to x equals 23. If nothing is specified, it's implied that we mean between these two x values. It's implied that these are x values that were given. So it's not a really hard formula to use, but we need to be a bit organized. So what I'm going to do is say, let's decide first of all that my 7 really is my x1 and that my 23 really is my x2, and just rewrite this using the 23 in place of x2 and using the 7 in place of x1 in both places where they appear. So they're in the numerator and they're in the denominator. Here I'm going to write this as 23 minus 7. The reason I'm doing this is it's going to make it easier after I've found f of 23 to make sure that I put that result in the right place. Sometimes people aren't very organized and careful and they get their numbers mixed up and then they end up having a sign error. But if I write it out like this, then I can come over here and say, let's just focus on what f of 23 is as a side problem. Once I've answered this question, I'll go ahead and plug it into the formula. Well, to evaluate f of 23, I would just plug it in for x. Plug 23 in for x. So that gives me square root of 23 plus 2. We can see what's happening here. Square root of 25. It looks like f of 23 is equal to 5. So that when I'm ready, I can replace the whole f of 23 with a 5. Next, I'm going to evaluate f of 7. And that's going to be the square root of 7 plus 2, which is the square root of 9, which is 3. So I now have the statement f of 7 equals 3. That means that I can come over to the f of 7 in this formula and replace it with a 3. Now if I rewrite this whole thing, it's simply 5 minus 3 divided by 23 minus 7. I'm ready now to just evaluate. 2 in the numerator, 16 in the denominator. It looks like this rate of change, this average rate of change is 1/8. And we can look at a graph of this function, the square root of x plus 2, from 7 to 23. What we're expecting to see with an average rate of change of 1/8 is that it is increasing because that rate of change is positive, or at least on average it's increasing between those two values, but not at a fast rate. That 1/8 is a pretty flat line. The rise relative to the run is pretty small. So we're expecting it to look almost horizontal over that run. Bringing you right now to Desmos.com, which is a really useful free website, Desmos.com. By default, it comes up in this calculator. I entered the equation y equals the square root of x plus 2, and then I also entered these two ordered pairs so that we could see the two ordered pairs on the graph. If we look at this graph, we can certainly see the characteristics that we were just describing that we expect to see. It looks like between these two marked points, the graph is increasing, but not at a very fast rate. It is fairly flat and, in fact, getting somewhat close to horizontal here. So that's how we see our rate of change reflected in the graph if we happen to have some graphing utilities handy.